properties, we will prove certain important inequalities such as Bernoulli's inequality. Okay, and first I will prove Bernoulli's inequality itself. So Bernoulli's inequality says that is a real number which is greater than -1, then 1 plus x the whole power n is greater than or equal to 1 plus nx for all natural number n. This is what Bernoulli's inequality. 1 plus x the whole power n is greater than or equal to 1 plus nx. Okay, now to prove the result, we will use mathematical induction. So first I will take x is greater than -1, and this is a fixed number. X is a real number which is greater than -1. I have fixed this number and I am defining P of n as 1 plus x the whole power n greater than or equal to 1 plus nx. I have to prove that this P of n is true for all n element of natural numbers. So first I am checking what is P of 1. P of 1 means 1 plus x the whole power 1 greater than or equal to 1 plus 1x. Actually both sides are 1 plus x itself, so that this is true. This is 1 plus x, left hand side is 1 plus x, right hand side is also 1 plus x. So this is true. Now I am assuming that P of k is true. That is, we have 1 plus x the whole power k greater than or equal to 1 plus kx. Now I am going to multiply both sides of this inequality with 1 plus x. So when we multiply both sides of an inequality with a number, the inequality will not change if the number we use to multiply is positive, and if it is negative, the inequality will reverse. Here we have x is greater than -1. So 1 plus x is a positive number. So I am going to multiply both sides of this inequality with the positive number 1 plus x. So that I will get, here this will be 1 plus x the whole power k plus 1. This is greater than or equal to 1 plus kx into 1 plus x. So the reason for this inequality is that 1 plus x is greater than 0. There should be that reason. Now this means 1 plus x the whole power k plus 1 is greater than or equal to, expand the right hand side, we will get 1 plus x plus kx plus kx square. Now this is same as 1 plus k plus 1 into x plus kx square. Now I am removing this term from here. I am removing this term so that I have 1 plus k plus 1 into x. Then we know that these two steps, the last two steps are not equal. The last two terms are not equal because here we have 1 plus kx square, and 1 plus kx square is missing in the next step. So what will be the sign here? What will be the sign here? We have k is a natural number and x is a real number. That is greater than -1. Let it be there. If x is a real number, then we have x square is greater than or equal to 0. Therefore, kx square is a positive number or non-negative number. So if you remove a non-negative number from this term, then this step will be greater than this thing. So here I have greater than or equal to. So the reason is that this is the reason. So what I have is 1 plus x the whole power k plus 1 is greater than or equal to 1 plus k plus 1 into x, which implies p of k plus 1 is true. So we have p of 1 is true. If p of k is true, then p of k plus 1 is true. Hence, by mathematical induction, p of n is true for all n element of natural numbers. Therefore, 1 plus x the whole power n is greater than or equal to 1 plus nx for all n element of natural numbers, provided x is greater than minus 1. This is Bernoulli's inequality and its proof. Okay, now I will move on to the next inequality, which you know, AM-GM inequality, which you have studied in statistics. Okay, so suppose A and B are two positive real numbers. Then root of AB, square root of AB is less than or equal to A plus B divided by 2. Root of AB is the geometric mean of A and B, and arithmetic mean of A and B is A plus B divided by 2. So GM less than or equal to AM. So we have to prove this result. Okay, to prove the result, here we have A and B are non-negative. This means root B and root A are real numbers. They are greater than 0. When you take square root, then it is greater than 0. And this means root B minus root A or root A minus root B is a real number. If you have a real number, we know that its square is always non-negative. So this implies root B minus root A, the whole square is greater than or equal to 0. What is root B minus root A the whole square? It is B plus A minus 2 root BA. So this is greater than or equal to 0. We can write this as A plus B minus 2 root AB greater than or equal to 0, since addition and multiplication of real numbers are commutative. Now add 2 times root AB on both sides, so that we will get A plus B is greater than or equal to 2 root AB, and multiply both sides with a 1 by 2, which is a positive number, so that we have A plus B divided by 2 is greater than or equal to root of AB, which is the required inequality. So this is our AM-GM inequality for two non-negative real numbers. And suppose in general we can state AM-GM inequality like this: if A1, A2, etc. AN are all positive numbers, then their geometric mean. What is the geometric mean of n real numbers? A1, A2, etc. AN, product of them to the power 1 by n is less than or equal to their arithmetic mean A1 plus A2 plus etc. plus AN divided by n. This is AM-GM inequality in general. And here we have proved it for two positive real numbers. Okay, now I will prove one more. Okay, here I have used one result The result we used here is if A element of R, then A square greater than or equal to 0. Now the next inequality is this. There is no name for this. If A and B are greater than 0, they are non-negative real numbers or just positive real numbers, then A less than B implies and implied by A square less than B square implies and implied by root A less than root B. This is what we have to prove. So A and B are given as positive real numbers. If A is less than B, then A square less than B square and root A less than root B and vice versa. This is the statement. So we have to prove this. For that, assume that A is equal to 0. So here I can use A and B greater than or equal to 0. If A is equal to 0, then A less than B means B is greater than 0. Okay, surely B square is greater than 0. Here A is 0, so this 0 can be written as A square. So I have A less than B implies A square less than B square. Okay, so if A equal to 0, the result is right. First part, this one. Now assume that A is greater than 0 and we have A less than B. If A is less than B, then B minus A is greater than 0. Okay, this is a definition for A less than B. We say that A is less than B if B minus A is an element of P. Element of P means it is greater than 0. And here we have A greater than 0 and B greater than 0 because B is greater than A. So whenever A is positive, B is also positive. So A and B greater than 0 means A plus B is greater than 0 or B plus A is greater than 0. Okay, so B minus A is greater than 0 and B plus A is greater than 0. Therefore, we have their product B minus A into B plus A is greater than 0, which implies B square minus A square is greater than 0, which implies B square is greater than A square or A square is less than B square. So, we have A less than B always implies A square less than B square. A less than B provided this condition is there. If A and B are non-negative, then A less than B always implies A square less than B square. Okay, now we have to prove the converse. A square less than B square implies A less than B. So, assume that A square is less than B square. This implies B square minus A square is greater than 0. This implies B plus A into B minus A is greater than 0. Product of two numbers is positive, means either both of them are positive or both of them are negative. But here A less than B and 0, both of them are greater than or equal to 0. This implies A plus B is surely greater than or equal to 0. If A plus B is greater than or equal to 0, then it is sure that B minus A is also greater than 0. Because product of them is greater than 0. A plus B into B minus A is greater than 0. And here I have A plus B is not negative. A plus B is not negative. Now, we can say that B minus A is greater than 0 or B is greater than A. Therefore, A square less than B square implies A less than B. So here we have a less than b implies a square less than b square, and now we have a square less than b square implies a less than b. Therefore, a less than b implies and implied by a square less than b square. Now replace a by root a and b by root b, so that we will get root a less than root b implies and implied by root a square, that means a, less than root b square means b, and here we have a less than b implies and implied by a square less than b square. So we have the required inequality. So I am concluding this session with this result, and we will move. You should do more inequalities and problems which are given in exercise, and we will start the next session, next module in our next session.